You need extra credit?
No, I was just
Actually, if you
wondering.
wanted to be super cheesy,
Well, you can come whenever you want, every Sunday.
Get that into there.
Huh?
And then
We always have like a some sort of coffee hour thing afterwards that pretty regularly. I mean, there's like not a guarantee each week, but I can kind of find out who's hosting it. I would say 85% of the time, it's not just coffee. It's baked goods and sausages and cheese and stuff like that. And then probably about 15 or 20% of the time, there's like a spread, you know, a brunch basically. What's this? Well, yeah, each week somebody like volunteers to do the coffee hour. But so, you have some of these people just love to cook. And they're like catering to gluten-free people, so they have like 9 different cookies, and 2 of them are gluten-free, and then there's carved prime rib, and so all right. So before we dive back into our project and kind of get it to a stopping point for break, let's talk midterm. Okay, so the midterm will be in about 5 minutes. We had that yesterday. Everybody take out a piece of paper. All right, so midterm is going to be 1 week from today. So the Wednesday that we come back. Okay, we're actually going to talk about the content of the midterm today. And I'll tell you a little bit about kind of what I expect to be on it. We'll go through the slides here. We will not have class on Monday. I will not be back from Colorado yet. Yeah. Yeah, I leave for Colorado tonight to Denver. I need to wait for the THC to clear my system before I fly back. Monday, I return on Monday, but not in time for class. Yeah, of course. I probably did.
Do we have 3:90 class then? Or are you not going to be?
No, I come back like literally like at 2 in the morning on Tuesday.
So we have class.
But we'll have class on Tuesday. I'll be on
Brownies
camp.
for everyone, right?
Huh?
Brownies for everyone?
I think special brownies.
Well, we can say possibly, but you have to think of the extent I might have to go to get this back through the airport security. You thinking about that, Dirty Randy?
Domestic flight is like 50-50 shot. You have crevices in your body.
My understanding actually, I mean, I haven't been through Denver since this whole thing started. My understanding is it's like really, really hyped and out externally, and when you get there, it's like nothing.
Nothing. Oh, isn't like it's just super.
Yeah, it's like not a big deal,
yeah.
If you're there. It's like kind of the newness is worn off or something like that. So I mean, I doubt I'll try anything. Well, my wife isn't going to want to go into those shops, right? I'm going there with my wife, so realistically, if a place has like drops or something to put in your coffee, maybe I'll try something. But
you can get a patch. Transdermal patch?
No, but I mean, the thing is, I'd only even consider anything like in the evening because I'm not going to go out because I don't know how it's going to affect me. I'm not going to go out, driving around a city that I don't know and, affected. So, but realistically, it's not something that really interests me, I guess. So I might want to go stake it out and just kind of see what that environment's like. But it's almost like the vaping around here, these vape shops. I don't have any interest in it, but it's kind of interesting when you check out one of those shops and you see all these the mods and stuff like that, and you go over to the corner for the really expensive Chinese stuff for the dried herbs, right? I go, what's that for, right? So I think I'm interested in the culture, not necessarily in the practice, but I guess we'll find out what happens in Denver, stays in Denver, and on the recording.
And that'll be all in the midterm.
This is a cover on the midterm. All right, so midterm will be a week from today. It'll be designed to take about the class period, so probably I'll design it to take like 40 or 45 minutes. So it shouldn't be a major time stress type thing unless you just completely don't know the stuff. There will be 0 programming on the exam, even though we're doing some programming right now to kind of see the computer science back end side of things. This isn't a programming-centric course, so I will not be testing you on programming in here on either the midterm or the final. You'll still have assignments dealing with some of this stuff, but hopefully you're already seeing these assignments are much more about structure than about logic. Okay, so I just want to emphasize that I don't want you to view this through the lens of being a programming class. I will not be testing you on programming in here. I'll test you plenty on programming in other classes. All right, so no programming. I suppose I might. It would be fair game for me to maybe show you a snippet of code and ask you something about it or something like that, but it wouldn't be a programming-centric question. It would be an operating system-centric question. It might make the most sense for me to give you an example in code than ask you something about, why did we do a queue this way versus something else or something like that. Okay. All right, so no programming on it. Expect about 8 to 12 short answer essay type questions. No fill in the blank or multiple choice or true false, none of that stupid stuff. I don't even understand why those exist. Yeah, and it's like it's like a cop out for grading, isn't it? Although but the reality is those tests are significantly harder to write. But you spend 3/4 of your time coming up with the wrong answers. What are the most believable wrong answers, right? To try to trick the students. It's far more entertaining to just ask open-ended questions and just watch these hilarious, inept responses. Yeah.
We just come up with multiple choice wrong answers that make no sense at all.
Yeah, like Bugs Bunny and
Those are my favorite.
Or in your case, maybe you put yourself down for an important question.
Yeah, but that would probably be the correct answer.
Yeah, probably. Who created the lit expression?
That's right. What mildly famous computer scientist once said,
Everything that comes out of my mouth
it's gold. It's gold. All right, so let's see. Any other things about the midterm in general before we kind of talk about what things I think are important, which things are not important? Questions. This will be a week from today, so.
Is there going to be anything from like previous classes? Because I know you like to pull in old stuff.
Well, I mean, it would be potentially fair game if it was related to this material and we brought it in here in context of what we talked about. I mean, I wouldn't
Computer sciences, problem solving.
Yeah, I mean, it wouldn't be just some random fact that you should remember from 2 years ago or something like that. It would have to be.
Convert this to hexadecimal.
Huh?
Convert this.
Well, but I mean, that's related to all this stuff.
Awesome.
Yeah, I mean, so that's not just randomly pulled out of nowhere. I mean, that's our computers, our operating systems, they store these things in that way, and they have to work with it in that way. So those are things you should know. Yeah, so here, we'll throw that on there. Conversion
Thanks, Austin.
is fair game.
Welcome, guys.
Speaking of The Martian,
Oh, yeah.
Matt Damon uses hexadecimal.
See?
Yeah, it's pretty sweet actually.
Yeah.
That's a really good movie. I highly suggest it.
Is that new?
Yeah. Really
It's
good.
huge. Everybody knows about
Yeah,
it.
see, I'm too busy cheating at World of Warcraft and writing software.
And kill dodos.
I haven't been killing dodos lately. I haven't played it in like 3 days. Been busy. Okay, so let's go to chapter 1 here. I'm going to kind of go through the slides, and I'm going to point out areas that I think are important. So I'm going to do this exact same thing when I actually write the exam. I haven't written it yet. So maybe I'll write it on the plane or something. And I'll kind of point out the things that I think are kind of interesting. something from history of operating systems, I could certainly pull from that. Kind of understand that difference between the 9X kernel and the NT kernel, where the transition happened, that kind of thing. Maybe understand the lineage of OS X coming from Next Computers when Apple acquired Next Computers with to bring Steve Jobs back.
Acquired what?
Next Computers.
Oh.
Next. OS X is essentially the operating system from Next with an Apple front end on it. What was that front end called? And I should just put that on this will be a question. So it won't be a question. But it was called Aqua. Aqua. We did mention it. It was one of those passing fact things. All right. So
What is Aqua exactly?
Aqua is the windowing environment. It was in the conversation we were talking. I think Levi and I were talking about windowing environments on Linux. And the rest of you we got him engaged, and we want to take advantage of that. So it's the window environment for OS X. Their front end windowing thing is called Aqua. Let's see. There could be a question on iOS versus Android, maybe the idea of fragmentation or something like that. I would probably say that's fairly low priority. I would have to be desperate for a question to ask something on that. Certainly something to do with goals of operating systems, what they're trying to accomplish for us, that kind of stuff. Maybe with an emphasis on this whole that an operating system is effectively a resource allocation device, allocation tool. Our computer is a collection of resources, and we need to have a way of allocating those things. What is a kernel? I mean, you should know what the bootstrap program is. The before the operating system. He's the piece of software that actually loads the operating system onto the computer. So there had to be a creator, Christian Werby. System calls, kind of where they fit in kind of the world of our operating systems in terms of doing I/O, and really thinking about these things is what we've been designing lately with our software. Is kind of a summary of everything we've talked about up to this point, right? So we have kind of this, we have our CPU, and then we have these different queues, and one of these queues is the device, or the waiting queue, as I usually refer to it, and that queue is all about doing I/O type stuff, and that happens through various system calls, and we have those system calls that live in a layer in our operating system. We think of our operating system as kind of like a sandwich, and so we have multiple layers of stuff in there, and each of those layers we have to pass through. So think of them like bouncers to a bar or something like that. Most of you aren't 21 yet, so you should never have stepped foot in a bar, right?
I think we talked about that stuff more in chapter 2.
Oh, whatever. I'm just kind of jumping ahead.
Talk about bars and
Actually, it's probably
Really?
quarters of them, sorry.
Who's not 21 in here? And who's never been in a bar? He is 21. See, it is funny. I don't know if it's well, it's certainly not ethical. But wouldn't you agree that it's, for those of you who are 21, that you're far more behaved since you turned 21 than you were before you were 21?
Nah.
Because it's no, well, no, I mean, like, you know,
You actually have to pay for it.
well, yeah, well, I mean, not just that, but it's like, yeah, that's it. The thrill's gone. So, like, you know, most of us probably had a drink before we were 21, right? Okay. Well, yeah, of course, just communion, Christian worldview. Thanks for the help. Okay. Okay. But the reality is once you turn 21 and you can just passively do it whenever you want, it's like the thrill's gone, right? It's like, you know, I go into places like, oh, well, I mean, if the wine's on sale, maybe. Yeah, but the funniest thing I've heard recently about a student drinking endeavor, they were all 21. We all know Steve Caruso.
No.
Yeah, so apparently he was the designated driver for this group that was going out. And he's telling me about, oh yeah, we went to this place that had all you can drink beer, so I drank there. By definition, the designated driver does not partake in all you can drink beer, right? I mean, you can argue whether or not one drink is a problem. But all you can drink beer? As the Yeah, that's not problem solving. All right. So, understand kind of where system calls fill into the whole operating system dealy thing. Volatile versus non-volatile storage. Non-volatile being like our hard drives and that kind of stuff. Volatile being like our RAM, our memory. The more volatile, the higher speed, the higher cost, the shorter amount of time it tends to hold on to information. And that kind of fills in with the whole cache stuff. So understand that kind of hierarchy of memory. You know, our registers, then L1 cache, L2, L3, then system RAM, and then you start getting into your, you know, hard drives and USB sticks and stuff like that. You just progressively get slower and slower and slower. Yeah, this guy. This picture. Oh, and just so you know, that whole conversion stuff, questions I like to ask about conversion in the context of operating systems are going to be, you know, I could see myself asking a question like, how many bits is a 2 terabyte hard drive or something like that? I like bits and bytes conversion, just like almost as much as I like numeric conversions. So remember that. As long as I'm in that mode, I like asking those questions. Similarly to internet connection speeds, I like the whole, you know, what is the maximum download speed in kilobytes of a 50 megabit per second internet connection or something like that. Making those jumps between bits and bytes and all that crap. So that would be from previous classes, though.
I don't remember that.
What? Theoretical, the maximum theoretical download speed. So a bit is a 0 or 1. A kilobit is 1,024 bits. A megabit is 1,024 kilobits. A gigabit is 1,024 megabits. A terabit would be 1,024 gigabits. And then on the flip side, you have a byte, which is 8 bits. Kilobyte, 1,024 bytes. Megabyte, 1,024 kilobytes. Gigabyte, 1,024 megabytes. Terabyte is 1,024 gigabytes. Then its exabyte is 1,024 terabytes, and so on and so forth.
So what was that second question? I don't remember discussing download speeds.
Well, we might not have discussed it, but it's still fair game. I just gave you the whole chart. I mean, that should be far easier than, I mean, that's just a little stupid math problem, right? You have a 20 megabit per second internet connection. You need to convert it to kilobytes. So divide it by 8 to get you over to the byte column, and then divide it by 1024 to get you to kilobytes. You're killing me. Isn't this like, is this the junior or senior level class? Junior and senior? So junior and senior computer scientists don't know the difference between a megabit and a kilobyte? I should make the entire exam on that. All right. Yeah, that's really bad because I would like partially expect if I walked into Best Buy that I could talk to one of their people and they might have a chance of getting that right. And I have a really, really low view of the Best Buy salespeople.
Do you really think they could?
I bet you some of their computer people could convert between a gigabyte and a megabyte, or some number of megabits for an internet connection, and how fast does that actually translate into real download speeds in terms of things that we know? Because it's from a technologist perspective, it's really important that we understand that stuff so we don't get taken advantage of. I mean, when you go out and buy a 50 megabit per second internet connection, if the first thing that comes to mind is you're getting 50 megabytes per second instead of 50 megabits per second, that's a far cry. It's a big difference between, bits and bytes. It's a factor of 8. So your connection speed is 8 times slower than you thought it was. is I guess the punchline. All right. Certainly forks and threads and child things and all that stuff.
Multiprogrammed.
Yeah, that crap. Well, I'm just throwing out concepts. I'm just letting the slides remind me. I'm not necessarily saying, what slide is this? Slide 34 from chapter 1. Know that. Okay, so these are concepts. So this also talks about some of our different scheduling stuff. So like lately we've been talking about process scheduling and CPU scheduling, and to a extremely high level memory management. Just somebody has to get the PCB created, drop it off to the process scheduler, that kind of stuff, kind of how that flow through works. Our process management stuff, PCBs, that kind of stuff. This is when we were talking about it at the really high level. Then in chapter 2 and 3, we talk about it more specifically. Memory management at the high level. Digital rights. Who cares about digital rights? And of course, be able to identify all the different dinosaurs visually. What's this guy? He's got 2 horns.
Did you tame that one?
Is that a Dilophosaurus?
Yeah.
I think that's a thing. I think it is a thing. Yeah. Something.
That's not it.
That's not it?
That's not
You sure?
He's a dinosaur expert. Come on.
Did you know that in his spare time also
That's
started as an archaeologist?
it.
No, that's not that's not horns.
Yeah, I was.
Oh,
saying
that's a Dilophosaurus. That's the guy. That's the spitter, right?
No.
Yeah. He that is the guy. He flares out and he spits like poison stuff on your face, and then he kills you in a jeep.
Yeah, you're
Poison
right.
stuff is actually made up. His natural habitat.
Kills you in his natural habitat. He drags you to a jeep. Okay. Possibly something dealing with command line versus graphical user interface and how we actually work with our operating system. So that would be more of a big picture thing in terms of how do we make our operating system do things? How do we communicate with our operating system? So here's that layer thing I was talking about where our system calls kind of live between our user interface and our GUI command line stuff. So, we have various ways of interacting with the user, which then has system calls laying between that. Those system calls give us access to the various resource subsystems of our operating system, so on and so forth, which ultimately down here at the bottom gets down to the hardware. Make sense? So kind of understand the different layers of our operating system. I don't think we actually said this, but in general, operating systems, just like security protocols, take something called it's an onion approach. We just keep peeling back until you get to the heart of it, except I don't think we necessarily view the center of an onion as being the really important part. But if it was, that's what an operating system is. All right, so you'll never look at onions the same way.
Operating systems are like ogres.
Like ogres?
I feel like artichokes is a better example.
Because you are trying.
Because you want artichoke hearts?
No. You don't really want the heart though.
I think there's all sorts of recipes around artichoke hearts.
Yeah, artichoke hearts are the important part.
That's like the thing.
Oh, it is a thing?
Yeah.
Okay, but there are layers of artichoke.
Right. So the point I'm making is that your example is actually appropriate. You didn't even know it. You thought that you were oh, okay, well, don't call me stupid. But unfortunately, I don't think, it would just be weird to say an operating system is like an artichoke. Artichokes aren't popular enough is the issue. They're like the nerdy kid in school that doesn't get picked for basketball.
They're like kale right now.
Artichoke is artichokes is the kale version of is the kale from the 90s,
It
right?
used to be artichoke was pretty good.
What about okra?
Quinoa.
That's only the South. There's 3 people left to eat those.
When I was
They're
younger,
like fried boogers. Have you ever had okra?
yeah, but it's weird. It does taste good.
If you think fried boogers taste good, then
No, see, you're talking more about the texture. It's where you're getting weirded out with it.
well,
They actually do taste pretty good. Well, actually, pretty much anything fried tastes pretty good, especially you dump gravy on it. There's this place we're gonna try when we get into town tonight. And I mentioned we don't have class Monday, right?
Yes.
All right, because I'm going to Denver and that's where the drugs are. Yeah, there's some late night spot that we're gonna stop at in Denver tonight that has this. I don't know. I guess Denver's big for these green chili peppers. They put green chilies in everything, something like that. And there's some place that has this smothered green chili burrito thing. So I'm gonna eat that right before bed. My poor wife. So yeah, apparently it's supposed to be the legit thing you're supposed to do before you die if you go to Denver. In Denver, it's supposed to be burrito, green chili burrito stuff. Apparently, it's some mixture between. Yeah, it's weird. They're a strange Tex-Mex fusion thing, and maybe it's what happens when you get lower oxygen amounts when you get up that high. Okay, so let's see. It's command line interface, GUI. We talked about some of the different shells. So the command line shells would be fair game, something along those lines. Again, still our system call stuff. So system calls are going to be kind of an important thing, but not so much specific system calls, because we really haven't talked about that. We've really talked about system calls from the perspective of they're our way of talking to the operating system, ultimately getting down to the kernel. We don't just go down there and play with the wires directly, right? We have to have some sort of mechanisms to go through.
Okay, so off topic, but have you ever heard of an API being called an API?
An API?
Yeah, like we have these workers that we outsource in the Philippines, and we had one of our developer calls last week, and he kept calling it API.
So you're making fun of Filipinos. Is that what I'm hearing? Is that what you're hearing, Dirty Randy?
Yeah.
I was just wondering if it was a thing.
Did he say it with like a funky accent too?
Yeah.
That makes it so much better. No, I don't know it to be a thing.
Okay.
But with that in mind, I mean, we all have kind of our different cadences we have for different things, right? So I say something. Well, like for instance, in here, the book refers to it as the device queue. I call it the waiting queue because that's how I learned it, years ago. So it's, yeah, but I haven't heard the API thing, but I might start it.
Worldview.
Well, it's like it's like a fun thing, right? Well, no, it could be a Christian worldview. The Filipino people, what's the?
Roman Catholic.
Oh, they're Catholic, so we don't even really. Well, we might need to convert them a little bit.
I mean, they're no need to convert.
Yeah. So, well, I mean, just a little bit.
Just reforming them. No.
Yeah. We're just reforming them. We're the Lutheran and bend, but yeah, we don't need to go full bore on those people, I guess. But I was gonna say, we might want to kind of drop down to their weird verbiage, talk the API thing when we're talking to the techno geeks there. That way we can introduce them to Jesus, right?
Well, they're Christians, though. That Roman Catholics are Christians.
No, I get it. We've already covered that. Yeah, so we don't need to completely go in and do. I mean, I was thinking that there might be something else weird going on down there. Yeah, so we're relatively okay. So the punchline here is that we maybe don't need to. See, are you Catholic? Is that why you're getting all defensive about this?
No,
Like, look, come on.
I'm not a Catholic.
Well, now you say that with such disdain.
No disdain.
Yeah.
Disdain's happened 500 years ago. I don't need that.
Somewhere in there was Christian worldview, I guarantee it. What's this guy? What kind of what's he doing?
Yeah, what is that pose?
It's like ancient dogs sniffing their butts.
All right. So yeah, let's keep kicking. Yeah, I almost guarantee I won't ask you anything specifically about, the system calls for certain operating systems or how Microsoft DOS executes things compared to FreeBSD. It's unimportant. Those are just specific examples. You don't even have to review those. Understand the big topics. Yeah, here's the layered thing, our artichoke approach to the operating systems.
It's like an artichoke.
Yeah, from like a top down, it's like an MRI of an artichoke.
What about a gobstopper?
But every part of the gobstopper is
Okay.
Concept of a microkernel. So the idea is that we pull as much of the important stuff into the kernel as possible, keeping the kernel relatively tiny, but with all the really, really, really important stuff in there. So almost think about our kernel as kind of like one of those fireboxes, where we build things around it to protect it, but it in and of itself has just the most vital things to the operating system in there. That would be the idea of a microkernel. Nothing with Solaris. Certainly virtual machines. something along the lines of kind of where they fit in the world. We wrote a paper on this, and kind of talking about virtual machines from the perspective of resource allocation on your machines, is also what we might use them for, that kind of stuff. All right. And then we're chapter 3 here. All right, so chapter 3 really gets into the stuff we've been talking about more recently, kind of the specifics of a process, the specifics of our data structures involving processes, our PCBs, those guys. What goes into a process, so program counter, data section, this kind of stuff. The different process states, new, running, waiting, ready, terminated. Things about that. When is a process in a new state? When is it in a running state? When is it in a waiting state? When is it in a ready state? So on and so forth. Okay, so understand this diagram basically. The idea of a PCB, what it's for, why we need it, blah, blah, blah. Whether it's a living thing in our operating system or something that we're carrying around between our various schedulers. The idea of context switching from our CPU. So CPU switching from one process to another, what's involved. When a PCB context switches onto the CPU, what happens? When a PCB context switches off of a CPU, what happens? And why do we need to do that? What's the purpose? The various queues that we have in the process scheduler. So the guy who's in charge of all the processes on the computer, what does he use those queues for, and how does it compatible with this diagram right here? I mean, this is fine, but you don't have to know this or anything. I mean, you should be able to read what this said if I give it to you as an example. But if I gave you any code examples, I would give you a Java example probably, since that's what you are familiar with. Understand some of the stuff about the specifics of how we've implemented our OS simulator and why. So again, not writing code associated with it, but I might ask you about the role of our queue factory or of our CPU scheduler or something like that in the context of our project that we're working on in here, okay, or simulator. Why we chose to do something a certain way, that kind of stuff. Kind of with the focus on the data structure side of things, which is very much an operating system concept, right? This idea of data structures is less about programming and more about our operating system has to organize our stuff in such a way that the various players that live inside the operating system can talk to the right stuff. All right, let's see if there's anything else in here that we... Oh, here we go. Forking a child in a box. Definitely will be covered on the exam. Oh, Pac-Man. Doesn't this one slide just make operating system so much more exciting? We got 2 dinosaurs, 2 Pac-Mans. We got some stars. This is multiple cores, right? And then we got this, whatever these are. I don't know if that's going in or coming out, but... The long-term versus the short-term scheduler, what I've called is, so this calls it the job scheduler. I've referenced it as the process scheduler. That's my kind of terminology for it. So long-term scheduler, job scheduler, process scheduler, all those guys are the same thing. What is its role? Short-term scheduler or the CPU scheduler, what's its role and why does it have to be super fast? How does that guy play into context switching? All that stuff. We haven't talked about that. Definitely context switching again. Very important. I can almost guarantee context switching will be on the exam in some form.
Contact or contact?
Context. Context switching. All right. Parent versus child processes versus parent and child threads and what the differences are. So when we fork a process versus spawn a thread, what implications does that have for the operating system itself in terms of who manages a forked process compared to who manages a spawned thread?
So, what is a spawn thread?
There's a spawned thread. It's a worker bee that lives within a process. So an individual process shares its own CPU time with its subthreads, as opposed to a forked process, which is scheduled independently of the parent process by the process scheduler. So danger of forking a process is that now the program that forked the process gets more CPU time potentially. Whereas a single process that spawns 1,000 threads gets no more CPU time than it got before. It just happened to split its CPU time among his own threads. What are the pros and cons of that? One's not necessarily always better than the other. Sometimes we want applications to have more CPU time, right? Sometimes we don't want applications to just be able to willy-nilly decide I'm going to take over your computer. I think we're kind of getting to the end. Yeah, so we're going to kind of start off after we finish off the last piece of our simulator. Actually, we may not even finish because our next piece is kind of transitioning into the next piece that we're not ready for yet. So depending on, I guess, my mood that day we come back, we might put the final touches on there. But where I want to pick up after the midterm is with this idea of inter-process communication. All right, so this is kind of the how we have our multiple processes on our computer talking to each other. All right, so now this kind of is, if we kind of connect this to our programming world from some of the classes you guys have had. So for instance, in the 390 class this semester, we've introduced the singleton design pattern, right? This idea of having a global object that multiple guys can talk to. We've seen it in here with our Q factory. We created a Q factory that both our CPU scheduler and our process scheduler could both talk to. So it lived in one place. So now we need to think about how does this translate to the operating system level where we have multiple interested parties in our operating system who are interested in maybe the same data. Or how does one process get a certain piece of information over to another process? Do we talk directly? Does this guy write something to here and this guy reads from there? How does he know when it's time to read from here? This kind of stuff. We're going to see a whole lot of similarities to things that happen in an operating system to things that we now are incorporating into our applications on a regular basis. And what's that evidence of? That's evidence of that our common applications are becoming more and more complex, and an operating system is kind of becoming more of a loose has a looser definition, I guess, where an operating system is a system that lets something operate. We always think about it in terms of our computers and all this complexity, a whole bunch of stuff happening all at the same time. But really, when in the 390 class, when we have an interface controller sitting behind, that's an operating system for that single view, right? I mean, that is the stuff that has to work for that single view to work. Right, so we can put these things in different contexts, but when we talk about inter-process communication, we're going to be talking about some different ways. Shared memory, message passing. A popular one is something called a semaphore that we'll talk about. We'll also talk about signals, and then we'll connect the dots to the observer design pattern in programming for that. Okay, so questions about the midterm? Pretty much know what to expect. All right, so like I said, the midterm will be 1 week from today. We will not have class on Monday as I will not be back yet, but I will have access to email and Slack. So If you do have questions as you're studying for the midterm, feel free to ask them on there. I will keep tabs on it and respond. Okay?
Gonna cover our homework next time or after the midterm.
Sure. What was the homework assignment?
Context switching.
Oh yeah. That's the part that we need to finish on the program, right? Yeah, that's easy. It was easy, right?
Well, when we were working on it, and you were telling him what we were doing was wrong.
Well, everything you do is wrong.
Well, yeah, but I didn't understand why.
All right. Yeah, we'll talk about it next time. So you should probably add to your list whatever you were doing for your homework assignment will definitely be on the exam.
Perfect.